Welcome to lecture 2.6, where we're going to cover the formal charges of nitrogen. And the way I like to go through this is I'm going to show you every single combination of both hybridization and formal charge, neutral, negative, and positive, for nitrogen, so you can get a comprehensive understanding of what nitrogen looks like at different charges and understand the trends so that you can quickly identify formal charge going forward in the course. So nitrogen is in period 15, which indicates to us that there's 5 valence electrons that it desires. That means that the neutral case, we're always going to want 5 valence electrons. Now, one thing to remember is that formal charge views a bond as 1 electron and a lone pair as 2. Of course, a bond has 2 electrons in it, but when we think about formal charge, we want to understand that that bond is sharing 2 electrons and the atom only gets 1. Understanding that and the octet rule, the way you get 5 valence electrons is going to need to be something like this. If we have a nitrogen and we treat it like carbon, we know carbon wants 4 bonds. That's only going to be 4 valence electrons. And that's not going to be good. So nitrogen is going to look something like this. And what we're going to have is an atom with 3 bonds and 1 lone pair. Now, if we think about the total valence electrons here, we have 3 valence electrons from the bonds and 2 that belong to the nitrogen, giving you a total of 5. Now, this is the sp3 version of nitrogen because all of the bonds are single bonds, but more specifically, the way that I like to view it, we have 4 distinct groups around. Now, with the sp2 form of nitrogen, we're going to need to add a double bond. But note that in order for nitrogen to be neutral, it's going to always need 1 lone pair and 3 bonds. So how are we going to make this? The answer is to keep it the same, but change the bonds. Instead of being connected to 3 single bonds, let's use 1 double bond and 1 single bond. By doing this, now we have a situation where the octet rule is still obeyed. We have 8 electrons around that nitrogen. We still have 2 electrons from the lone pair and 3 from the bonds. But if we count the number of groups around the nitrogen, we can see 3 distinct groups. So this is the sp2 version of nitrogen, and a new functional group that you won't even see in this course, but I still want to illustrate that the fundamentals apply universally. Once again, this is going to give us 5 valence electrons with the sp2 hybrid. Now for sp, we're going to need 2 groups, right? 2 letters, 2 groups. So we have our nitrogen. Let's triple bond it to something, but make sure that it still has a lone pair, right? Because it needs that lone pair to get 5 valence electrons. We have 3 bonds, 3 electrons from the bonds, 2 electrons from the lone pair. We now have 5 valence electrons. So these are the neutral forms of nitrogen. Now, my strongest advice to you is to I would memorize the neutral forms for carbon, for nitrogen, for oxygen. The reason, and I wouldn't memorize these. The reason I say that is that we covered this principle last time. The idea that if you want to gain electrons, you need to convert bonds, which are worth 1 electron, into lone pairs, which are worth 2. This is the only way that you're able to actually gain a negative charge without violating the octet rule. Going backwards, remember that if you're going to lose electrons, then you have to take those same lone pairs and convert them back into bonds. So why do I bring that up? As long as you remember this rule, and you know the neutral states of your atom with 1 lone pair and 3 bonds, then all you need to do is remember the orientation that this works, right? I gain electrons by trading a bond for a lone pair and vice versa, and apply that here. So what do I mean by that? Let's assume that you have this memorized. How do I make this negative? Well, to make this nitrogen negative, I need to give it an electron. It would need 6 valence electrons. Give it 1 extra electron and it'll become negative. But in order to do that, right, this atom is full. I can't just add another bond. I'm going to have to take one of these bonds and trade it and turn it into a lone pair. that would look something like this. A nitrogen with 2 lone pairs and 2 bonds. Now, when I count the valence electrons here, we have 2 electrons from the bonds, 1, 2 from this lone pair, 1, 2 from this lone pair, and that adds up to 6, as we predicted. So this nitrogen indeed has a negative charge. Right? And so you'll see that when nitrogen has 2 lone pairs, it's negative. Let's see if that follows across the different hybrids. We'll take the same nitrogen from here. If I make it double bonded and give it 2 lone pairs, right? So essentially all I've done here is trade this bond for an extra lone pair. We now have an sp2 hybrid, which we can quickly verify by counting the groups. And then we can say, all right, well, we have 2 electrons here, 2 electrons here that belong to the nitrogen, 1 electron from each bond, gives us a total of 6 valence electrons, which confirms our negative charge on the nitrogen. Excellent. And with the triple bond, there's actually not going to be a way to keep the sp. If we remove one of these bonds for a lone pair, we're going to get right back to where we were. So this one doesn't really exist. Now, looking at the positive charge, we'll have to go the other way, right? Remember that if we want to be positive, we're going to have to lose our electrons, which means that we're actually going to trade our lone pairs for bonds. And this is why I like to memorize the neutral form. To make it negative, we traded bonds for lone pairs. To make it positive, let's do the alternative. Let's add another bond instead of that lone pair. So for the sp3 nitrogen, that would mean 4 distinct bonds. For example, if those are hydrogen, this is the ammonium positive ion, NH4+. To break this down, we can see that now that there are 4 bonds, we have 4 valence electrons. And since nitrogen wanted 5, that is actually going to make us positive. Looking at the sp2 from our neutral starting material, we could say, well, let's trade that lone pair for a bond. And once again, we've made a positive nitrogen, 4 bonds. Something to think about here is if we compare this to carbon, all of these states, all these positive versions of nitrogen, that's the setup that makes carbon happy. Carbon wants 4 valence electrons, so it wouldn't be positive in that situation, but nitrogen is. So it's key to understand the differences between the heteroatoms. Lastly, we have the triple bond. This one we could theoretically make positive by simply removing the lone pair and trading it for a bond. By doing that, we now have 4 different bonds making 4 valence electrons. So a nitrogen in this situation would both be sp hybridized because it's connected to 2 things, and it would also have a positive charge because it has 4 bonds, when usually nitrogen wants 1 lone pair. So with this little table, this encapsulates every single form of nitrogen that you're going to see in organic chemistry, and also solidifies this key rule that helps you move between positive and negative without memorizing everything. I would recommend, however, once again, that you memorize the neutral forms. Now that we've covered nitrogen, it's time to move on to oxygen.